Welcome back to Advent of Code 2015. I managed to do 7 problems yesterday. That's good. That's like a quarter of the way. All right, day 8. All right. Matchsticks. Space on the sleigh is limited this year, and so Santa will be bringing his list as a digital copy. He needs to know how much space it will take up when stored. It is common in many programming languages to provide a way to escape special characters and strings. For example, C, JavaScript, Perl, Python, and even PHP handle special characters in very similar ways. However, it is important to realize the difference between the number of characters in the code representation of the string literal and the number of characters in the in-memory string itself. Okay. So, quotation marks is 2 characters of code, but the string contains 0 characters. Yeah, okay. ABC is 5 characters of code, but 3 characters in the string. So this one is strangely basic for 8. Yeah, well, they vary. There's no. It's not that it consistently gets difficult or anything. Sometimes you get easy ones later on as well. So we got. Yeah, welcome, Amara. It does look. Okay, so this one. 1, 2, 3, 4, 5, 6, 7. Alright. I mean, it looks like this is very easy to do in Python using the... and this one is just 1 character, right? Yeah. That is apostrophe. Is that a typo with the triple quotations? Where? Here? So that middle one is escaped as a backslash, so they want that one. The quotations actually appear in the string as opposed to just in the code. Santa's list is a file that contains many double-quoted string literals, 1 on each line. The only escape sequences used are backslash, backslash quotation, and backslash x plus 2 hexadecimal characters. Disregarding the white space in the file, what is the number of characters of code for string literals minus the number of characters in memory for the values of the strings in total for the entire file? Wait. We don't even need to parse this. Literally just turn it into a string and count the number of characters. Let's see. This is a job for eval. I mentioned eval the other day. This is where eval shines. Okay. Alright, so we've got our strings. So let's just say so what is the final result we want? We want the total number of characters minus, so number of characters in this text file basically, minus the number of characters that actually get end up in the in-memory string. Okay. So we want num... Oh. Zoom in a bit. Can't remember what the zoom in button is. Hang on. What was it? It was Alt Shift. There we are. Okay. So we want num. Oh, I'm having problems with my shift key. I might need to use the right shift key. Damn it. Okay, num. Why does this thing keep popping up? Oh, it's not even visible on stream. There's a pop-up window which keeps IntelliSense thingy. Alright. Num. Cars. So we want... Let's how to distinguish it. Call it num code. Yes, I have, DJ. The caps lock key is now broken. It seems F1 and F2 are also broken, so it's that whole side of the keyboard. I think they're all just wearing out. Strange about F1 and F2, I don't really use those keys, so I think it's a circuitry thing. Yeah. I was playing Assassin's Creed the other day, and I used caps lock to run. And I was like, why all of a sudden he just started walking, and I couldn't get him to run. I was like, why is he walking? I was supposed to be saving kids from a burning fire, and I was walking in there to save them. I thought the game was bugged, but it was actually the keyboard. Right, num code cars equals 0. That would be a good idea, actually. Yeah, I mean, actually, it would be better for my wrists to use a standalone keyboard. And the heat from the laptop is not comfortable either on the hands. Yeah, I probably will do that. It's just one additional thing I didn't really want to carry around in my suitcase, but I think I can justify it. It doesn't even have to be a heavy one. Num string. Keep pressing. Okay. Yeah. So we want num plus the length of so we do, however, want to strip off the new line character because they're not including that. So it'll be number of characters there. And it's basically just length of eval. So eval will run the string as code and return the result. So just do that. We want do you really need a val? As opposed to what? Because I mean, in this line, yeah, because otherwise it'd just be the same as the line above. But are you talking about a different approach? So let's try running this. Won't it be the same amount? No, because eval will run it as code. So it will be rendered as an in-memory string. So first of all, the quotation marks will not count towards the in-memory string, and also these backslashes will no longer count as well. So it should be lower. Let's try it. 1333. So that's the difference between the two. I don't know if this will be right though, but seems like it should if eval does all the things I'm expecting it to do. Yeah, that's right. Yeah, because they only did a few things. So yeah, it was the ASCII characters and the escaped quotation marks and the escaped backslashes. Yeah, so Python knows how to do that, and I imagine other languages. Well, no, JavaScript can do that. I think there's something equivalent to eval there. The other languages you might need to write a parser, but even that wouldn't be that hard because there's only 3 cases to check. But that's the beauty of Python. They had lots of problems like this, which could be solved with eval. I remember it becoming a meme that in the forums or on Reddit when people were doing these puzzles that people were struggling for hours, and then Python users were just typing eval. Alright, part 2. Let's go the other way. In addition to finding the number of characters of code, you should now encode each code representation as a new string. And find the number of characters of the new encoded representation, including the surrounding double quotes. Huh? So we're taking the code. Oh. We're now making a string that represents that code. Okay. A string that would display that code. Ooh, does Python have something that works backwards? So it's like we take the string that we see. There is a thing called encode. for strings. I don't know what it does. Let me have a look. So wrong window. Print test.encode. I don't think this will actually mean that. Oh, no. Yeah, okay, fine. So if I want. So if I have a quotation mark in there. No, encode is not. No, that's something different. Okay, so basically we want to add escape characters. We can do that manually. I was just wondering if there was something in Python which would do that. So for each quotation mark, we add one for the backslash. For each backslash, we add one for the backslash. So when we see this, it would actually end up being backslash, 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 quotation mark. Oh, so it's not as complicated as going the other way because it's not ambiguous. And when it comes to x61, it's just the backslash. It's literally just, you just count the backslashes and quotation marks. And that's the extra count you add, right? Hello, back down off. Is the goal to print the strings from the file? No. The goal is to it's hard to put in words to create a code representation of that string. So you would want a piece of code which if you were to set like x equals that thing, then you would end up with this string. So an example would be let's say this one here. So if I wanted to end up with that, I would say test equals quotation mark, and then I would want a backslash quotation marks. Hang on. Oops. I would add that at the start and at the end. That would cover the quotation marks. So every string you're adding four for those, because you always have to have quotation marks. And then I would also have backslashes to escape these backslashes. So if I did that, and I were to do print test, what we would see would be exactly that string. Because of the way I've escaped it. Okay, so I think so if we want a new count, which is num I can't even think of a word, but let's just call it pre-code. cars. We would want, so we add 4 for the quotation marks, which are always at the front and the end. 1, 2, 3, 4. We count how many backslashes there are, how many quotations there are. Okay, so we want quot count equals line dot strip but ignoring the first and the last characters. Well, we don't have to ignore the first and last ones. Okay, so quote count equals dot count so we're counting how many quotation marks there are in that string, including the first and last ones. We want to do the same for backslashes. Like that. So we do this equals length line dot strip plus quote count plus backslash count, because we have to add 1 backslash for each of those characters. And then what, do we add 2? Let me have a look at this again. Yeah, because we have to have the outer quotation mark, so we have to add 2. I guess there is no need to put escape character if you put double quotes in the single quote. Oh yeah, good point. In fact, that wouldn't even... What would that even do if I did it like that? Would it be the same? But yeah, you're right. I don't need that. Okay, and then what did we want exactly? Number of characters of code in each original string. Okay, fine. So we want the this one minus let's try that. Why is it negative? Oh, whoops. I'm supposed to be using... Wait. Oh yeah, plus equal. Huh. Plus equal. Why did I... Hang on. Do I want line dots... Do I want this thing? Or do I want... No, I want eval, don't I? No. I do want the raw string. Yeah, that's right. Okay. 2046. Okay. Oh, escape characters always confuse me. That was a little confusing, but it was I mean, it was a simple problem at the end of the day, but especially for Python, but it did confuse me a little. Day 9. Hang on. All right. Every year, Santa manages to deliver all of his presents in a single night. This year, however, he has some new locations to visit. His elves have provided him the distances between every pair of locations. He can start and end at any 2 different locations he wants, but he must visit each location exactly once. It's like a traveling salesman, basically. Traveling salesman problem. Shortest distance he can travel to achieve this. That's precisely the traveling salesman problem. For example, given the following distances... No, it's not, because... Oh, no, yeah, it is, because it's exactly once. Not at least once. He'll end up hating Santa. London, Belfast, Dublin, okay. So this is just a combinatorial problem. We can do it using brute force. Ooh, but that's quite a lot of oh no, how many cities is that? That is quite a lot of cities though. But I think brute force will still be able to handle that. 1, 2, 3, 4. How many lines is that? 7, 8, 9, 10, 11, 12, 13. It's about 30 or something. About 32. 30. Oh, so 30 factorial. Is the number of permutations. That's a lot. Wait, how many is it? How many lines is it exactly? Oh no, that's not the number of cities. No, the number of cities is 1, 2, 3, 4, 5, 6, 7, 8. It's just 8, and then all the rest, all the other paths. Okay, it's just 8, so that's. If you just try all 40,320 different permutations, and then just pick the one which is shortest. So, seems straightforward enough. Python is good for permutations. Python's good for everything. That's the rule of thumb, but it is actually very good for permutations because you can use the iter-tools combi library. Okay, so we want a distance table, just record all these to begin with. We just want to say for every pair of cities, we want to know the distance, so I mean, We could type these all in manually, but let's just write the parsing code. So just those town names though. So Alpha Centauri is what, the nearest star to our galaxy, other than the sun? No, sorry, that's Proxima Centauri. What's Alpha Centauri? Just another star. Alright, so from the Sid Meier game. But is Alpha... I thought the Sid Meier game was based on a real... Well, maybe they did make it up for the Sid Meier game. I know Proxima Centauri is a real star. Theron is the main D&D setting. Oh, really? Norath. I'm sure I've heard Norath before. Is that going to be like World of Warcraft or something? Alright, so we want line.strip. Yeah. I do need to get myself a new keyboard. Snowdin is Undertale. Oh, really? I played that a few months ago, but I didn't remember the name. Cool. Norath is EverQuest. Is EverQuest still running? That's quite an old one, isn't it? Alpha is the star system and Proxima is one of the stars there. Ah. So Proxima Centauri is in Alpha... in the Alpha star system. Okay. Okay, so we split on the equals. So the right-hand side is the distance. So we just say distance equals int of r, and the towns, town 1, town 2 equals... Alpha has 3 stars close to each other. 2 of them, if I'm right, have the same center mass. I see. I've never played Sid Meier's Alpha Centauri. Maybe I should. I've played like all his Civ games. All right. Come on. Split on the 2. So that'll get us the 2 towns. So we want to say dist of T1, T2 equals D, but also the other way around too. Okay, so we've got, let's have a look at this. Okay. All right. Now we just want to try. So they are asking us for the shortest root which covers all towns. So let's just create a set. For all the towns. Okay, so we want to use Python's tools permutations. Don't remember how to use this. Permutations. So the iterable will be towns. I don't think if we just leave the second parameter blank, I think that just gives us the full, not combinations, but just the full, let's try it, start printing them. There should be a lot. Yeah, that's all the orders. Okay. Okay, so yeah, shortest equals, say, none. All right, so so if given a permutation, let's say just for I in range length R, Z, we add the distance between every successive pair. We don't want to go off the end here. So dist so we take I plus 1. Okay, so that Z should now be holding the total distance of this path. And then shortest equals min shortest Z. Wait, we need to initialize shortest to, well, let's just see what happens. Yeah, okay, so shortest needs to be something. I don't know. 9,000 is a big number, whatever. 117. Could also print out the path. Okay, correct. Next here, just to show off, Santa decides to take the route with the longest distance instead. Easy enough. We just do that again, but so the longest will be the max. 909. I mean, that was a very easy part 2 if you've solved part 1. So unless someone did part 1 in a kind of convoluted way, which didn't naturally extend to the longest, then I would think that's very... It's I mean, yeah, it was very easy to code that whole problem in general, but I wouldn't say it's not really the easiest problem, because I think some people might get stuck on that. They might not know about permutations, which is a bit more mathematical than... I mean, problem 1 was the easiest. Oh, the easiest part 2. Oh yeah, I agree with that. The way I did it, yeah. I can't even think how you would do it in a way where part 2 was difficult. Maybe if someone... don't know. Probably some... I mean, if some people were writing their own permutation script and they were kind of baking the minimum calculation into it, then they might need to do a bit of fiddling around to make it also get the largest. I don't know. But yeah, so that is the traveling salesman problem, which in general is... I mean, if they had increased the number of towns to what? Let's see. So if we go to like 12 factorial, it's that big, which is almost a billion. Yeah, I would say around there, that already is becoming infeasible. So if they increased it to 12 towns, that's too many. But yeah, for those that don't know, traveling salesman problem is this. It's precisely that. You have given a list of sites. You need to visit all the sites in the shortest path. But it is an NP complete problem, meaning we do not have any fast way of solving it. Not even on the fastest supercomputers in the world. But there are lots of ways of relaxing the conditions or finding approximations, so you can get answers which you can guarantee are within a certain bound from the true optimal, and you can quantify that bound as well. But getting the exact answer is just really hard. I got to the graph problem today and was not able to solve for an hour, not even close. Graph problem. Which, are you talking about Advent of Code? And which year? Oh, Code Wars. One second. Let me bring that up. Training on the bee. Oh, it's like hexagonal. They can move down, right, or right. Interesting. Number of ways the bee can crawl from cell A to opposite cell B. Ah. Yeah, this uses... I've seen variations of this problem come up a lot. It's a dynamic programming problem, isn't it? Cool. Code Wars. I've heard... I mean, Code Wars is quite popular, isn't it? some of the popular sites I used to use are shutting down, so I might have to switch to some other sites like Code Wars, things like that. All right, let's have a look at my... Oh yeah, this was the... Okay, yeah, we got 18 stars. Oh, we got to get the full... What is it going to be? 100, 200, 300, 400 stars before the end of this year. That's our goal. 10. Alright. Today the elves are playing a game called Look and Say. Is that a real game? Oh, it's the Look and Say sequence. Yeah, I remember this sequence. It's where you... It's where you... You just say out loud the previous term to get the next term. So that is 1, 1. So you put 1, 1. That is 2 1s. So you put 2, 1. That is 1, 2 and 1, 1. So 1, 2, 1, 1 and so on. They take turns making sequences by reading aloud the previous sequence and using that reading as the next sequence. For example, 2, 1, 1 is read as 1, 2, 2 1s, which become 1, 2, 2, 1. Okay. Look and Say sequences are generated iteratively, using the previous value as input for the next step. For each step, take the previous value, replace each run of digits with the number of digits followed by the digit itself. Okay. So we apply this 40 times, giving the starting input. Okay, that's a nice problem. This is one that doesn't require any knowledge or anything. This is just good. This is just good practice for the very basics of programming. All right, so ten. So we start with that. They don't need to be integers. We might as well just make them strings. Okay. So we want to define a get next given current. So we want to say okay, we can write this method in a really nice compact way. Let's say if s is an empty string, just return an empty string. Okay. Otherwise, we just take the first run and see how long that run extends. So Ka is going to be the first character. So I equals 0 while I is less than length S and S I is the character, keep increasing I. So this is saying we're just putting an iterator at the start and we're moving it by 1 over and over again until we reach a point where we found a new character, and I is going to be sitting on that just before that new character. Or it would just be sitting at the end of the string. Okay. So that's a run. So we'll say C equals length of S up to that iterator. That's how many characters there are in this run. This would be a nice one for an exam. Yeah, this is good. Good to teach. Good to practice using pointers and iterators in strings. So we want to say. So the answer will be. So we would say. C. So C is the count. So if there's like, okay, in this case there's 3 ones at the start. So we'll take 3. Put the character. So we're saying 3, 1. And then we just call this recursively on whatever's left. I think that's it. All right, so, okay, but we need, so we take the seed, the starting seed, we do this 40 times, okay. Seed equals get next seed. And then what? Just print. Come on, caps lock. You've still got some juice left in you. I believe in you. Oh yes, I can still use caps lock, but this is actually going to slow down my coding. Yeah, I really do need to get a new keyboard. The thing is, you don't really find a lot of computer or technology shops here in India, or at least here in the countryside. This isn't like Thailand, where it's very Thailand. We have there's a lot of smartphone shops and computer shops and technology shops, but India is not quite the same. But I will be going to Vietnam next week. I think Vietnam is pretty good with technology. I might hold off until I arrive in Vietnam. Get myself a new keyboard. So it's just the length. I mean, it probably would improve my gaming as well. Like, easier to hit the keys. Right. We exceeded the recursion depth. Well, how long are these strings? It's just... I didn't think they would get this long. I guess 40 times is quite a lot. Yeah, okay. We can do something very naughty. Very naughty. Never do this at home. This is how you crash your computer, and I did this in Advent of Code last year. I actually crashed my computer after increasing the recursion limit. So let's go with a safer limit than I did last year. Let's go with yeah, it was bad. Like everything ground to a halt. The stream was sort of hovering, but all the programs I couldn't switch windows, and then it was just a full-on crash. But I had set the recursion limit to like something high, like hundreds of thousands or something. So let's go for, I don't know, 5,000? Yeah. You have a recursion limit for a reason. Alright, how far did we get? Oh, you want to go higher, do you? I mean, you can write... Okay, this is the proper way to do this, is to write it in an iterative way. You can always do that. But we mathematicians like to do things recursively because it's just like elegant. Alright, come on. 10,000. How far can we go? I haven't... maybe let's see how high we're going here. Print. We got to 28. Damn it. I might have to write this in an iterative way. Well, these numbers are still okay. Okay, we'll go to 50,000. Close. Computer didn't crash. There was a default recursion limit 1,000. Yeah, I mean, I've overridden that to 50,000. We got as high as 34. Where did I go when it crashed? It was I think I might have set it like 1 million or something when I crashed it last year. So I think we can go higher than this. Let's go 100,000. Oh, it's slow at calculating this as well. I wonder if... Is there any trick to doing this faster? Because we are probably repeating a lot of old sequences, aren't we? But... Memoization, that might be the key, because we're repeating a lot of old strings as well. So if we've already computed a string before, we can just reuse that old string, all the substrings. Yeah, let's try and implement that. I think that will speed things up. This is ground to a halt. Okay, so can you show the task once more? Yeah, sure. Alright, I'm gonna hold this. Kill, kill, kill. Yeah, that was already starting to... that's not safe. Let's just stick with 50,000. But yeah, I think memoization is the way to go here. I'll just get myself another drink as well. So yeah, I think we are doing a lot of repetition. We're doing sequences, like even small sequences over and over again that we've computed before. So if I stick in memorization, I think this might just be what we need. You can also follow along on your own browser if you want. You just have to go to the Advent of Code website and okay, 2015. Actually, let me just paste that. Okay, so mem, just put a come on, caps lock. Nah, we've got to start learning how to use right shift. Man, how have I gone my whole life without ever using right shift? It's just not a very useful key, is it? I don't see what the point in it is. Well, okay, we've just found out what the point is. It's when you lose your left shift, you have to move to the right shift. All right, so if s in mem return, I use right shift for question mark. So is it like I think in proper typing, like if you learn typing properly, you're supposed to use the right shifts for the keys on the right, and the left shift for the keys on the left. I've never taken proper typing course. I feel like I probably should at some point. It might actually help. It might if I improve my habits for how I use keys and stuff, it might actually improve my coding, because I am often switching to my index fingers, which is not good. Right, return mem s result equals okay, do that. All right, I think this might just work then. Let's try now. Ooh, still slow. Oh, is it actually pulling from the... Interesting. I thought this would just rapidly speed everything up. There's still a lot of strings, I guess, that aren't completely new. Maybe I should just write this completely iteratively. It's not that hard. It's just I love just piggybacking off recursion. It will be faster as well because of the stack. It's keeping the stack. Am I actually pulling from memory properly? There's a function that would make this easier, I think. Is it like... I know there's some methods you can use, like tail recursion and stuff, which would just turn this into a... Yeah, this isn't good. Alright, stop. Also, I'll put the limit back on. Let's try and do this without fiddling with the limit. Okay. Right. So I'm not. I'll don't need to worry about this now. Okay. So So we just... same as before, but we just have an iterator. Okay, let me get my coffee. Do you need the recursion? What if you just cycle 40 times and just count and set to a string the result each time you go through the string? Well, that I'm not sure exactly what you mean, but I think that is basically what I'm trying to do now. Just do it completely in one pass. Do it in one pass of the string, instead of breaking the string up into segments, because that is costing overhead the way I was doing it. So yeah, I think that's what I'm trying to do now. So I want to say let's set I equals 0. Let's get rid of this. While I is not reached the end of the string yet, so we do sort of this process. So we take the character that is there. Hang on, we want a result, just a list of strings we stuff in there. So we take the character, we create a new variable j, because j is going to indicate where that character stops. J equals I plus 1, while j is less than length of s and sj is so while we're still looking at the character, we push j forward. So we push j until that run is stopped. All right, then we say the count will be the length of I to j. That's how many of that character are present. We'll say result dot append the string value of the count plus the character itself. And then finally, just to reset the process, we say I equals j. So we're bringing I forward now. So it's a two-pointer approach. And then we go back into the loop with this new value of I. And this will stop because eventually we'll hit the end of the string. And eventually j will be at the end of the string. I will be set to that, and then we terminate, right? So, and then we return the joined value of result. Let's get rid of this memoization as well. Try running that. Boom! That was quick. So much for recursion. Yeah, I see the problem now. I did it wrong, actually, the way I did the recursion. Well, it wasn't. So the problem was, every time I'm taking those substrings, because of the way the Python, because strings are immutable in Python, so it's rebuilding an entire new string every time. What I should have been doing, instead of using a string, I should have been using a list of characters, which is subtly different, because that's mutable. And I should have pointers into that list of characters. So the recursion is never creating a new string to pass to the next function call. Instead, it's just passing pointers to the next function call. And those pointers are pointing to that original list of characters. So you never mess with that list of characters. That's static. And the pointers are the only ones that are changing. So that was the problem. It wasn't, the recursion limit was also another issue, but the problem was I was just using so much overhead and rebuilding and destroying strings over and over again, when you never need to do that. You just need one static string and you just need pointers looking into that string. Let's try stack data structure. I guess the code will be beautier, but in Python, basically stack is basically list, isn't it? itotools.groupby. Ooh, what's that? I'll look that up. Okay, let's try this. Try this result first. That might be one of those things I need to start using in problems. All right, that's correct. Ah. Wait, so... Interesting. I'll have to read this in more depth later and maybe practice with it. I don't fully understand it, but it sort of looks like something that'd be very useful. I think itotools in general, I need to look at everything in itotools, because there's probably a lot of good stuff there that I haven't been using. Okay. Part 2. Now, starting again with the digits in your puzzle input, apply this process 50 times. So literally change 40 to 50. All right, is this gonna suddenly crash? Okay, we'll see. I don't know. I feel like it should be okay. If these numbers are okay, it's not exactly gonna explode exponentially from here. All right, so part 2, we can just take this and do it 10 more times, right? Just so I can keep the part 1 result. I just like using underscore. All right, it's taking a while for the remaining 10, but we got there. Using an underscore is weird. I mainly do it just because it's more, I want to remind myself whenever I come back to that code that I did not use that iterator. If I put J there, I might worry that J is being used somewhere later on in inside that loop or something. But underscore makes it clear to me that I'm not using it anywhere. It's just a throwaway variable. All right. I mean, yeah, if the first 40 are right, you would expect the 50 to be correct. It's just a question of whether you can get it running. Yeah, so my recursion approach wouldn't have worked for 50, certainly. But I think I could have written that recursion properly using iterators instead of copying strings, and I think it would have worked. I probably still would have had to deal with the limit, but I don't think the recursion limit would be too bad. But yeah, I think writing it full on iteratively is probably the correct way to do this anyway. So yeah, that was a good problem, and it's accessible to someone who doesn't, has just learned the basics of coding. Because recursion is kind of an advanced thing. Like when people start coding, they don't use recursion. They do it the way I eventually did it. Write things out completely explicitly using pointers. That ended up being the better approach. I mean, if you're working in a company or as a software engineer, you should always be using that approach, iterative approach. You should never be using recursion. Recursion is dodgy. It's not readable. You get you risk having stack overflow. It takes a mathematician to understand why it works. It's like iterative is really always the way. It's just recursion is just really beautiful when you write like a 2-line recursion and it just works. All right, we're on problem 11. I'm almost halfway. Corporate policy. Santa's previous password expired and he needs help choosing a new one. To help him remember his new password after the old one expires, Santa has devised a method of coming up with a password based on the previous one. Not a great policy, considering the whole point of a new password is in case the old password may have been compromised. So if you're basing it on the previous one, that's kind of a... Anyway, corporate policy dictates that passwords must be exactly 8 lowercase letters. So he finds his new password by incrementing his old password string repeatedly until it is valid. So increasing, okay, fine. Passwords must include... Oh my god. Can you imagine having these password requirements? Okay. Passwords must include one increasing straight of at least 3 letters, like ABC, BCD, CDE, and up to XYZ. They cannot skip letters. ABD doesn't count. So you have to have somewhere in your password, you have to have a run of at least 3. Okay. How on earth does that help your password, make your password less crackable. If anything, it's the opposite, right? It reduces the unknownness of your password because you know they have a run somewhere in there. Passwords may not contain the letters I, O, or L, as these letters can be mistaken for other characters and therefore confusing. That's an interesting policy. I mean, there's some reason to that, yeah. I's and L's, especially when you use different fonts, they can be confusing. Meanwhile, Twitch doesn't allow password length to exceed 72 characters. Passwords must contain at least 2 different non-overlapping pairs of letters. Like A, B, B, or Z, Z. Okay. Like how everyone thinks the tree in Final Fantasy IX is called Lifa when it's Aifa. I haven't. Final Fantasy IX is next on my list. I've played up to and including 8. I finished 8 last year, so getting there. Although I might go back and play 6 because I never finished 6, and 6 seems like a really good game to finish off. So I'll probably do 6 again before I carry on with 9. Like literally the only Final Fantasies I ever finished were 1, 7, and 8. I played all the others, but I never really finished any of them. They always got kind of boring. Towards the end, they were a bit grindy. But 6 was good. It still got boring at some point, and I left it, but I would happily give it another shot. Alright, for example, okay. The rules are clear enough, I don't need to follow the examples. Alright, given Santa's current password, what should his next password be? Okay. There's a nice rebalance mod for 6 that makes it much better. Ooh. Yeah, maybe I'll do that. Because I usually avoid using game-changing mods my first playthrough, but because I've had, you know, an attempt on the original, I would happily throw some mods into the mix. Alright, so this looks easy, unless I don't think we have to be smart about this. It's literally just increase the password one by one until all these are simultaneously satisfied. I don't think we have to find any clever methods of skipping ahead. Okay, so okay, so we basically need 2 methods here. One is given a password, get me the next password in sequence. In other words, increase the characters. And the other method is given a password, tell me if it's valid, satisfies the conditions. And those conditions do actually look pretty easy to code. All right, so let's start with the get next. What's the cleanest way of doing this? We can use recursion here because we're not dealing with huge stacks. So we can say if the last character is Z, then we do get next on the first part of the string and just change that to A, the last character to A. And if it's not Z, we simply increase it by 1, right? That's it. So if S well, let's do A first. No. If it's not equal to Z, so if it's not equal to Z, we just do. What happens if you add 1 to hang on. Can you do this? No, you can't. Is there something in Python which literally just increments a string to the next character along? Okay, we'll do this just write this out explicitly. So it's not equal to Z. Return so we take everything except the last character. Plus, and then the next, the final character we need to do ORD, so that converts it to the number. Add 1, and then turn it back into a character. I don't know if there's a cleaner way of doing that. But... So, okay. Else, oops. So in this case, the final character is Z, so we want to do get next of the first part and combine it with A. Z rolls up to A. Yeah, we're basically redefining incrementing a decimal number, aren't we? But on a string. Okay. Right. So the other method we want is define is whoops valid. Okay. So the conditions are Okay, first condition. There must be an increasing straight of 3 letters. ABC, like ABC, BCD, CDE, and so on. Okay, so we can do that using the ORD method. So rec1 equals any. So given an iterator, if we want to verify that from this iterator these 3 characters are run, we would say ORD SI plus 1 equals ORD SI plus 1, like that, and the same but 1 character long. So that condition says, given an I, given a position, yeah, the next character is 1 higher, and the next character is 1 higher than that. Or I in range length S minus 2. Is it 2 or 3? Oh, this always confuses me. So yeah, 2. All right, so okay, so that tells us if we've got a run somewhere in the string of 3 characters. Okay. Rec2 equals oh, this one's straightforward. There's no I, O, or L. Okay. Not any car in S for car in IOL. And then finally, it must contain at least 2 different pairs of letters, like AA, BB, or ZZ. Okay. This one. So we want to count how many letters from the alphabet satisfy. So across all the letters of the alphabet, we want to count how many times we see that letter as a pair. and then just check that that count is at least 2. So I want to say sum across car. So I want car plus car in string for car in A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. So that counts how many times we see AA, BB, CC, so on. We count only 1 each time we see that happen anywhere in S. And we want that at least 2. That gives us 2 different pairs. All right. Return rec1 and rec2 and rec3. So now we just say while not is valid password equals get next password, print password. We can actually verify by hand that this will be a valid password. Oh, yeah, this is okay. There we go. So does that look correct? So we've got an XX and we've got ZZ. So that satisfies condition 3. There's no I, O, or L in here. And is there a run? XYZ. So that's valid. Is it the oh, and it doesn't look like it's far from the original password. So that looks right. Wait, what were the question? Was the question asking us for the? Yeah, it is actually asking us for the password. So let's test it then. Nice. Santa's password expired again. What's the next one? Okay, fine. Just do it again. So we just need to get the next one to begin with. All right, will it take longer this time? Okay, so we've got ABC, we've got AACC. Yeah, that looks plausible. Woo! If I complete 12 and the first part of 13, I will actually be exactly halfway in terms of stars. Still got half an hour before I want to cook dinner, so I can keep going. Well, let's go for 12 then. All right, this is a shortly described problem. All right. Santa's accounting elves need help balancing the books after a recent order. Unfortunately, their accounting software uses a peculiar storage format. That's where you come in. They have a JSON document which contains a variety of things: arrays, objects, numbers, and strings. Your first job is to simply find all of the numbers throughout the document and add them together. Is this going to be a case where we literally do JSON.loads in Python? For example, 1, 2, 3, and oh no, JSON.loads is actually not. I think it's easier just to like use regular expressions or something. You want the minus symbols as well, so what is the cleanest way of doing this in Python? So yeah, JSON.loads is actually not that useful because we'll have nested objects. It'll be a bit of a pain to actually extract all the numbers. It's literally just a string problem, isn't it? Just find all the numbers. I think this is a regular expressions problem, I guess. All right, let me save that. Because we want to make sure not to discard the minuses. All right. So this is just one big string. Okay, so we want... So let's try using regular expressions. This is good practice at the very least. It's just one line. Line equals not that it really matters about stripping it. Okay, so pattern equals, how do we do this? How do we do regular expressions? It's like that represents a digit, one or more digits, right? And we want to include the minus sign if it's there. How do we do that? It's like minus. All right, I'm gonna have to use the regular expression builder. I can't do this like from scratch. Let me, where's the regular expression builder that I always use? Regular expression builder. All right, so we want whoops, no. Okay, so we want, so if I do this, D plus, that gets us all the numbers. Now to include the minus sign, we need is it just question mark? 0 or 1, yeah, okay, so we want minus question mark. Yeah, that's the pattern. Okay. M equals... How do you do this again? re.match pattern line. Then what do you do? Is that just going to be a list of all the matches? Wait, what do you do with that? No match was found. Oh, I think we need to complete this with... Is match the right thing? Maybe we want dot. Oh, I think I know what the problem is, but yeah, we want sub, don't we? No. Search? Let's try each of these. So match is checking whether the whole string fits that pattern, which it doesn't. Okay. Let me just Google this. So I want Python RE find all matches. It's re.findAll. There we go. Okay. This is good practice because I need to get better with regular expressions. It's so important. Print. So we want print sum of map int m. Is that how you use map? There we go. Yay! All right. Stand back. I know regular expressions. So the other way you could do it, I guess, would be parsing. You just find all substrings which are starting with a character which is not a minus sign or a digit. Yeah, but that, I mean, regular expressions is the clean way to do it. I was tempted to use JSON.loads, but that would just give you a bunch of objects, and then you've got to try and find the nested objects which have ints in them. Yeah. All right. The next one. Uh-oh, the accounting elves have realized that they double counted everything red. Oh, balls. Ignore any object and all of its children which has any property with the value red. Do this only for objects and not arrays. I think this is where we do actually use JSON loads. They call them objects, but really they're like dictionaries. Okay. Yeah, you can do it with regex if you But it's probably better to just cut. Let's have a think. So ignore any. We want to ignore any of the dictionaries essentially, which has any property with the value read. Okay, so we can cut them out of the string whenever we find. So I would say we look at our string, we check if there is any red object in there. We slice out that substring, which is the whole red object, and then go into a while true loop where we keep checking if there's still something in the string, which does that. When we finish that, there should be no red object in there, and then we can just carry on with. Regex is one of the few things I use in both translation and coding. Yeah, it's something I've not used much, and I need to use often. I mean, Python ties in nicely with regex as well. Okay, I think. Let's see where to go with this. So. Okay, so while true. So we're going to keep checking the string. Okay, we can still use regex here. So we want to say, is there a match for, all right, let's, so we want to find a match for this pattern. So we want an open bracket, then we want just any characters. Well, okay, so if we do but then we want red in there, so we want like this. There are brackets over the whole thing. Yeah, that's true. We need to just cut those out. So we want the smallest ones so we need these these dots, they need to be not brackets. We need the innermost ones, don't we? So actually not dot. We need that, a gated set. And then we need another one at the end. Well, yeah. There we go. That gets the smallest, the minimal objects. Let's read this again. Any object and all of its children, yeah. So if it recursively, if red appears, the string red appears anywhere within it, then we want to cut that out. So as long as we go for the smallest such, that's fine, because even if it's contained in another... Wait, hang on. So if a dictionary contains another dictionary that has red in it, we need to cut out the bigger dictionary. So this is not quite right. If we cut out the smaller dictionary, we're leaving the bigger dictionary still valid, but it shouldn't be. The bigger dictionary also needs to be cut out. So actually we need to find the biggest one, not the smallest one. Uh-huh. Oh, so what happens if I take this out? We end up cutting out all that, but that's... So red is a property which is indeed in this object here. But how much should we be cutting out? Let's have a look at these examples so I understand this. So that's... You could do... bracket dot star but you don't need any square brackets, do you? Because you might not have any square brackets. Like you can have just a dictionary like this, which has red like that. So as I understand it, we're trying to find the largest object. So basically, It says to ignore red if it's not an object. Yeah, but any object and all of its children. Let's see. So middle object is ignored. Okay, so they're saying that object is cut out. Fine. Oh. Alright, so that's cut out. In this one, the entire structure is cut out. So they don't. The example I'd like to see here is if they had red inside. Alright, but it does say and all of its children. So I think if the string appears anywhere, even if it's inside a bracket, in square brackets, inside, as long as it's inside. Okay, so I think we just, instead of using regex, find a curly bracket, find the corresponding closing curly bracket, and look if it, and check if red is inside that. If it is, cut out that whole thing, and then go back into the loop. Like, the problem with using regex here is regex can't tell us where the correct closing bracket is for that opening bracket, because it just treats them as characters. We need the corresponding closing bracket. What's that? With the comma. But regex will just find the first such, but it could be that there's several closing brackets until we get to the one which matches the original one. Regex has no way to determine which is the correct one. Basically, you need to keep a counter. Every time you open a bracket, you add one. Every time you close a bracket, you close one until you get back to 0. That's what we need. All right, it's not... Okay, I think I can see how to code this without regex. Let's try and do that instead. I mean, the other approach is actually to load it as JSON. Then what would happen? You'd have a bunch of objects, but you'd still have to... Yeah, no, I think doing it with strings is probably easier here. So, so while, so we're going to keep checking this string. So we're going to say, okay, so why JSON loads doesn't work? Well, it does, but it doesn't get us... What do we do once we've done JSON loads? So we'll have a nested object with all kinds of stuff in it. What do we do with that? Like we would then have to write some sort of we want to find every dictionary, and that includes ones that are nested deep within some other objects, which has red in it. Which you can do, but maybe we should be looking at this the other way around. Maybe we should find red and work backwards. Find the string red. And then find the... largest object which is containing red. So the outermost curly brackets that red is sitting in, delete that. Well, this is so confusing. Maybe that's the better way. So yeah, we look for the string red. If we find it, we look outwards until we find the outermost object it's in. Cut that object out. And then rinse and repeat. But if it's not contained in any object, then we'll just rewrite red to be blue or something, I don't know, just so that we don't accidentally find that again. Yeah, it is a recursion problem either way. It's just what order to do things in. All right. Okay, there's another. Maybe I'm worrying too much about making this string like final. I think what we can do is just in this loop, we just find the first open bracket, find the one which closes that open bracket, that corresponds to one dictionary. Check if red is in that string inside between those brackets or not. Either way, whether it is or isn't, we then cut that whole thing out so we never deal with it again. But if we cut it out, we either, if there was red in there, then we add 0 to our count. And if there wasn't red in there, then we add the number of digits found. Okay, let me try and explain this as I'm doing it. So we basically we keep cutting out. We don't want any objects, any dictionaries left in this string. So each time we take one out, we check if red was in it or not. And then we'll be left with something which just has no objects in it. Just a bunch of lists and arrays and stuff. And then for that final string, we just do the pattern that we did before. So let's just keep some running total here. So we want while So, I mean, isn't the whole thing one big object? Or not? Hang on. No, it isn't. This is what it looks like line by line. Okay. So that open bracket, I think its corresponding closing one is not the one that's at the end of the file. It's just somewhere it's closed somewhere, and then there's a comma, and there'll be another one. Submit 0 and check. Well, I mean, if I write this properly and it spits out 0, then I guess I could do that, but I don't think it will. Okay, so I reckon, okay, let's start doing this. So while, so I want to say while there is still any opening bracket in line, every time, so in this loop we'll just keep taking out these objects. Okay. So I equals line dot find. So find the first bracket. Okay. Now we need to find the corresponding closing brackets. Which means we have to let's say level equals 1. We want to get back to level 0. So we're in 1 level of depth here. And we want to find the corresponding closing brackets. So from I plus 1 length line if so J is ranging from the next character long till the end of the string. The character is line J. It's too complicated. There are many corner cases, such as if the name contains a bracket. What name? Name of what? The key in the dictionary. I don't think it does. I mean, if you're right, that could be within the rules, but it looks like that's not the case, so we can just kind of trust that that doesn't happen. But I mean, JSON.loads I don't think there's still a bit of work to do even if I do JSON.loads, so I don't see it being any easier. So if we assume that that never happens, then we're trusting every open bracket and close bracket is the start or close of an object. or array. So character is line J. If char is a new open bracket, level, we increase the level. Elif char equals close bracket level. Right, if the level is now 0, we've found the correct closing bracket. So we break out of this whole for loop. So if we've reached here, we should now have J being appointed to the closing bracket, right? So yeah, okay, so now we have two things to check. So that substring going from I to J, just check if the string red appears anywhere in there. If for brackets in string, it's better to use stack. You put bracket, and if you pull the opposite one, it means you got to the lower level and so on. I don't understand. What would you put in the stack? Because we're just trying to find the correct closing bracket, right? So now we just want to remove that whole object from the string and keep repeating this while loop until there's no more objects in the string. So if I cheat for this one, how would you cheat? If there's a fast way of doing it, I wouldn't say that's cheating. I'd say that's actually just what I'd do. How would you? You mean like do it manually? I feel like that would take longer. Using something like Sublime Text to separate into lines and deleting the objects manually. I mean, that's a valid way of doing it. But I mean, I think I'm almost there now. I just need to write the bit which deletes that section. So if red not in so if there's no red in there, that means we can add this to our count. We can add all the digits we find here. So we just say, do this. We don't need to reuse, we can reuse the pattern. So m equals re.find all pattern in line, hang on, let's say sub equals line I A, B, C, A minus 1 plus. If you put in stack, then you pop, you get A minus 1. Put isn't this just more work than what I'm doing, because I essentially what I'm just trying to do is find the point at which we hit 0, which is the matching bracket, right? But here you're actually storing information as well as finding the... But I'm still not clear on what you're putting in the stack. Like... And these are not the types of brackets we're looking for. We're trying to find the curly brackets. Line I plus 1 J. Okay, just do that. Sub. So M. And just add that to the count. So total plus equal that. Okay, so that's only if there's no red in that sub, then we'll add the count to our running count. And either way, we'll now cut that whole string out, so we don't have it anymore. So we say now line equals line up to I and line from J plus 1 onwards. So now there's no more object. So if we get here, we can have a look at what this looks like now. I don't think there'll be any more objects in here. It'll be an empty string. What's the total? Zero. So we are taking out the outermost object, but isn't that correct? This is weird because according to the rules, this... Wait, where is the corresponding bracket for this? It's not the final one. Oh, it is. Doesn't that mean the whole thing should be 0? Because there is actually a red inside this outermost object. So don't the rules mean that... I don't really understand this. Or are the outermost curly brackets a different meaning to the... Well, I don't think it would be 0. We could try, I suppose, but I don't want to try unless I'm sort of confident that it's 0. I'm still trying to understand these rules, though. Okay, let's go back to the... Ignore any object and all of its children which has any property with the value red. So it doesn't necessarily mean it's and its children's children and its children's children's children. It just means... Ignore any object. Yeah, these examples are not... There's not enough examples here. There's more complex examples which I still don't know the answer to. still don't know what the rule means for them. Like, what if there's an array which then has an object inside it which has an array which has red in it? Like, what does that mean? The original object is invalid? I feel like these rules aren't clear enough. So in this example, that gets cut out. Fair enough. In this example, maybe it's a bit simpler then. So maybe they actually mean... So when I read children here, I thought they meant descendants, like any level of depth into that object which has red in it, which would mean the entire JSON object gets destroyed, is invalid. But what they mean here is... It's not, it's this, I don't think this is written unambiguously enough. Because what does property mean? They have not defined the term property. That's the issue that I'm having. What does property mean? So if we're assuming it's simpler than what I was working with, so it's actually just one level. We don't go any deeper than that. So if it's an object which has a key value pair where either the key or the value is red, like something like that. But it doesn't matter if red is, say, in place of this 2 here. If this was red here, this 2 was red, that would be fine. But if red is here, so this one is fine, it says. And if there was an object which had this one in, would that object be valid or invalid? From this reading these rules, I can't say what the answer to that is. I don't think it's fully explaining. So I'll have to assume the answer is if there's an object which has this inside it, that object is still fine. Because otherwise, that means the whole sum is 0, right? So in that case, we just have to cut out the objects, the smallest objects which have red in them, right? Which means the original regex approach might actually be what we need. So if I go back to this, so I open bracket, and now we want no other open brackets. And then we have red. Let's just do that. And then after red, we have another bunch of things. Okay, it's that. If we're going with that, hello, Sukantian. What language are you using? I'm using English only. Don't know any other languages, I'm afraid. Okay, so now that gets us these objects. Now the question is, what do we do with this? Talking about programming languages. Python. Only Python. Was that question in English that you wrote? It looked like that was in German or something. Language. That's not German in the slightest. I wouldn't know. I don't speak German. Okay, so the question is, this first one here, do we cut that out? Yes, because red is in there. But if that red there wasn't there, would we still cut it out? Because there's a red here. That's what I don't know the answer to, and it's not clear from this description whether the answer is yes or no. What are you trying to regexify? The description says we're supposed to remove objects which has any property with the value red. But that to me is ambiguous. So basically any curly brackets which have red between them. But that to me is ambiguous because I don't know if it's... I'd say arrays are considered valid. So that red, you don't consider that to be a property of that object? Fine. So regex doesn't work here. Because regex would tell us to cut that whole object. But if that red wasn't there, it would still tell us to cut that whole object. So we can't use regex here. We do actually have to go back to json.loads. Probably. You can probably still use regex. How would we do that? Because the problem is there could be an array with another object inside it. I don't like the description of this problem. They could have done this better. So here you've got an object inside an object, right? So you can have objects inside objects. So if there's red inside this one, okay. If there's red inside this one, I think we do cut out the entire object. I think that is actually... But they don't have an example for that, but... Do you need to match objects inside objects also? What do you mean by that? The thing is, this whole thing is one big object. So if we were to... So I think the answer is... Well, the answer would... The total would be 0 here if we were to assume you delete an object if red is anywhere inside it. So we can't go down that path. So I think we have to assume that it's only red if it's a key value property of that object, and not if it's in any of its children. So an object which has red either as a key value, like besides this colon, in that object gets deleted, that object gets discarded. But if there's a nested array with an object inside it which has red in, we don't want to delete the outermost object, basically, is what we... So this regex is not correct because we are allowing open and close brackets because there could be nested objects inside there. It's just... Mosquito. All right. I mean, okay, if we're assuming it has to be the red should be a key value property of the original object, then we can actually modify what I've done already. We can say I don't know. I don't understand this problem at all. I gotta choose an approach here. So let's just say we only discard an object if one of its keys or values is red. That seems to be consistent with their description. Using loops would probably be really easy, but that's no fun. I would go for easy. Easy. I just want to get this solved. I don't see anything that's easy to do though. So I think I'll just go with this assumption that it has to be a key value pair of an object. In that case, what do? We can say we can look through all the objects in the Alright, here's an interesting approach. We could just do what we were doing before. Right. But we say so while, okay, we just keep looking for objects. If we find one, we find this code is just finding the corresponding closing bracket. Okay, so we've found an opening and a closing bracket. We're just trying to decide now if this should be discarded or not. Because if it has red in it, then it should be discarded. But it has to be red as a key or value of the original object. So this bit here is wrong. It's too generic. Get rid of this. What we want to say is, okay, we're looking at an object now. We want to check now if red is a key value of this object. So we could now use JSON loads, couldn't we? To interpret this as a dictionary and check if red is in the keys or values. If it is, then we just cut this whole object out and then repeat this. If it isn't, then this object's fine. We can leave it alone, but we don't want to encounter it again. So we could I don't know. Hello, don't call me late for dinner. Is the JSON not parsable? It is. But, I mean, what would I do with it if I were to load it as JSON? That's the question. By the JSON module. Yeah, I can do JSON, import JSON. I'm just trying to figure out what to actually do with that information. I think this is probably the approach we have to write some sort of recursive method. This is probably not helping. Let's comment this out. Yeah, do you know do you have a link to the site? Did you catch that? It's Advent of Code, and it's 2015, and it's day 12. Okay. Yeah. So I mean, I for sure I need to use JSON.loads. I've already settled on that. I'm just trying to figure out how to. All right. I think we need to write a recursive thing here. So let's say just call it JS, I don't know, equals JSON dot load. Is it load or loads? What's the difference? Loads. Line. So that is that is one big object, okay. Yeah, okay. So define num count. So this is a method which finds all the numbers in an object following this rule. but okay, yeah. So numCount is a method which takes a dictionary of this form and either returns 0 if one of the key values was red, or it returns the number of digits, and then we just call it recursively. So numCount of if the string red in js.keys. So if any of the keys is just the string red and nothing else, so if they're a nested thing, it doesn't matter. Or red in js.values, we return 0. So otherwise, we just call this recursively on each of its objects. Wait. So the object that we pass to this might be an array, or it might be a string, right? Those are all the possible things it could be. So or it could be an integer. Well, what are the different objects we can have? String, integer, array, or another dictionary. Excuse me. Okay, so let's say if type JS is int, return JS. If type JS is string, no, str, yeah, return 0 because a string is just going to be a color. Okay. If type JS is list, return sum of num count z for z in JS. All right, so that handles all the other possible cases. So at this point, the only thing left is dictionary. If any key or value is red, we return 0. Otherwise, return num count of the key plus num count of the value for all the key value pairs. I don't... Okay, this feels a bit flimsy. Sum. We want the sum of all these. Alright, does that look good? And then we just literally want to just call this oops, yeah, num count on the original JS. Alright, is that going to error? 65402, does that sound like a plausible number? It's less than the first number, which is good because we've cut out the reds. It didn't error, so let's just try it then. Alright, I mean... yeah, it's right. I don't like the wording of that problem. If they had... I don't know, I can't say how they should have worded it, but I'm pretty sure there would have been a wording of that problem which I would have been like, okay, I know what to do, but they should have said if an object has either of its key or value being read, like this is my problem here. Property, any property. What does the word property mean? They got to be more specific. If they just replace this phrasing here with for which either its key or its value is read, that's all they need to do, and then I would have been happy. Sukantian, you're actually close to solving it with regex. Okay, that's cool. Let me know if you succeed. The problem with regex is it can't handle nested logic, right? So, I mean, if you manage to get it, that's great. But there's a theorem in mathematics called what is it called? Something about a pumping lemma. Essentially, regular expressions is called regular expressions because you're looking for regular languages, okay? And I think what we're trying to describe here is not a regular language because it has certain properties that's more complex than a regular language. So this is getting into automata theory, so this is quite complex stuff. So I think when you try to describe a pattern which is not regular, then you can no longer use regular expressions for it, essentially. And I think what we're trying to describe here is not regular. But if you manage to get it working, then that's great. But it needs a lot of workarounds to make it work. What's regular mean again? So a regular language is a formal language that can be defined by regular expression. Anyway, this is going into a bit of depth here, but that's not just regex, so also that's not Python. Oh, what is that? Is that someone's solution to this problem? Or is that interesting? Yeah, it's in a different language, I guess. But yeah, that seems Interesting. It's using MapReduce. So yeah, MapReduce is, I guess, some sort of it's just a way of accumulating it over the whole thing. Yeah. The accumulator will be the count, and the operator will be plus. Yeah, that's the reduce bit. Cool. All right. That was a good problem with that one exception that I don't like the wording of this property here. But if they had just, if they had said that properly, if they explained it in terms of key values, then I would have liked that problem, because it's a nice recursive method that you have to write for this. Having ambiguous questions is very common in AOC. Yeah. Last year's, I think he did a pretty good job. I guess, I mean, this is the first year, so it's understandable that he might have learned from his mistakes over the years. Last year, I was pretty happy with it. I did not have any issue with ambiguity in any of the problems, I think. Some people did, but I don't necessarily agree with their complaints. I think in some cases, I think in all cases, I thought the descriptions were good and mathematically precise and clear and unambiguous. But I think over the years he must have managed to improve his specification and his language. Because this was the first year, I don't know what it was like then, because I wasn't doing it then. I don't know what kind of audience he had back then, because how do you make a site like this and get people to do it? Like, what do you do? Do you just post in some like special interest forums? Hey, I'm making a site. Do you want to try this competition out? I don't know what it was like then, so I don't know if there were even many people doing it. Or did he already have like a group of people who were into this stuff because they were doing it on some other site, and he's like, okay, I'm now putting these problems on my new site or something like this. I don't know what the situation was, how he actually got people to move to this site. So what do the stats say about 2015? Well, it's gonna be the stats up until now, so it's difficult to this is up till today. I don't know what it was like in the year that he released it. It might have been very few. So this is several thousands to today. I don't know what it was like then, but yeah, so this is how many completed it right up until today. And also, by the way, if anyone wants to join my leaderboard, you're welcome to. That is the code right there. You would have to copy that. I guess I'll put that in the description in my Twitch thing so that it's actually copyable. Yeah, I guess I'm done for today then. Well, actually, let me just copy that into chat. All right, so cool. We're halfway, technically just under halfway, but yeah. It might take me longer per problem from now on. If the problems are getting harder, I don't know. Oh, sneak preview. We're not allowed to sneak preview. It has to be a surprise tomorrow. But yeah, this is fun, and we've got lots more to get through. I'm aiming to complete this all before Christmas. I don't think that's realistic because I kind of want to leave a month or two gap between these because it's a bit heavy doing a lot of these streams. It's possible. Yeah, no problem. I guess it is becoming increasingly popular to stream Advent of Code. I've noticed more people appearing on Twitch doing it, YouTube as well, and people are going back and doing past years as well, which is great. Engagement is definitely increasing. It's getting more and more popular. In the live competition as well, you know, the day it releases. Christmas is, you know, on Christmas Day, everyone's waking up and going to their desk so that they can solve this instead of being with their family. That's great. I approve of that. Yeah, I will put this video up on YouTube eventually along with all the others as well, so it's like I've got a place where I can see all my problems. It will also help me understand all the inside jokes, because I see in the forums when problems are released, new problems which are kind of like similar to ones from several years ago, people are saying, oh, it's like so and so, and like people are like, oh, don't remind me of that problem, that gives me nightmares. And I'm like, I'm not in the know because I wasn't there then. So if I go through all these past years, I'll be able to understand all the inside jokes and all the references and stuff. But yeah, JSON.loads, that's another thing that Python can do, which is great. If you weren't using JavaScript or Python, then you'd have to write some sort of parser, I guess, which is not pleasant for this problem. All right, I'm done. Thank you for watching, and I'll probably be back tomorrow around the same time. I don't see anything that's going to stop me. I'll have enough time tomorrow. All right, bye-bye.